this question says, complete and balance the following reactions. Remember to form the stable product and then balance. Assume the product is solid. What type of reactions are these? So the first one we have magnesium plus oxygen yields something. So in order to find this stable product, we can't simply, add these together. We can't assume the stable product is MgO2 because we have an Mg and an O2. We have to use the charges to find this solid product. So in the past, we learned about naming, and when we did that, we learned that magnesium is in 2A, so it forms plus 2 compounds. Oxygen, it is in 6A, so it forms minus 2 compounds. Magnesium likes to lose 2 electrons to be like the noble gas neon. Oxygen likes to gain 2 electrons to be like the noble gas neon. So those are the common charges. So what we need to do is, once we have the charges, we need to cross them. So in this case, we have Mg 2 plus and O 2 minus. We cross the charges. And what we'd first get is Mg2O2. But you'll remember if there's a common denominator between these, which there is if they're the same number, right, it would be 2, then we would cross those out. So essentially, we want to cross these out, and we write MgO. And in the question, it tells us that this is going to be a solid product and an ionic compound and no water around. A solid product is what you would form. So this is the stable product based on the charges. Now what we need to do is we need to balance it because chemistry is not magic. We can't, in this case, make an oxygen disappear. We started with 1 magnesium and 2 oxygens. In the products, we only have 1 oxygen. It says we made an oxygen disappear, which of course is impossible. So in order to not have that happen, what we need to do is to balance it. So if we have O2 here, we have to make a minimum of 2 MgOs, because if we have 2 of these, we need to have 2 over here. And if we need to make 2 MgOs, we need 2 Mgs. So this is a balanced chemical equation. Note that when we're doing this, stable product from the reactants, then balance. It has to be in that order. Do not assume the product is MgO2 because MgO2 doesn't exist. All right, Na and Cl. So this one you may be familiar with. So Na is a 1A metal, and it's plus 1, and Cl, is a halogen, so it's minus 1. So we have Na plus Cl minus, we cross them, and we get NaCl solid, which again you may be familiar with, and have known you would have gotten that. So we write the stable product. Now we need to balance. Well, what's the minimum number of NaCl's we can make from Cl2? We can make 2 NaCl's. Then, if we make 2 NaCl's, we need 2 NAs, and this one turns out it balances exactly the same as the other one. They don't all look like that, but that's how that one works. Let's look at the next one. We have Al and O2. In this case, aluminum oxide is going to be the product, and that you would find in sandpaper or something like that. So find your aluminum. It's a 3A metal, so it's plus 3. Oxygen still in 6A, so it's still minus 2. So we have Al3 plus and O2 minus. Cross them, and what we end up with is Al2O3 solid. Now we need to balance. Well, in this case, we have 2 oxygens, and over here we have 3 oxygens. So we need to find a common multiple, which in this case is 6. So in this case, the minimum number of these we can make is 2. That'll give us 6 oxygens over here. 2 times 3 is 6. In order to have 6 O's over here, we need 3 O2s. Now we need to worry about aluminum. For aluminum, we have 2 Al2O3s. Well, each Al2O3 contains 2 Als. Said another way, you multiply this number by this number, and we have 4 aluminums. So we need to put a 4 here in front of aluminum. Last one, CaBr2. Well, Ca on your periodic table is in 2A, and Br is another halogen, so it's minus 1. So we have Ca2 plus, and Br minus. We cross them, and we get CaBr2 solid. Now if you look here, we have 1Ca, 1Ca, 2 Brs, 2 Brs. Just by coincidence, all the stoichiometric coefficients here are 1, and it turns out if you just had a written CaBr2, the convenient product, if you will, you would get the right answer, but that's just a coincidence. All of these reactions are one thing plus another thing yields one thing. So we have two things yields one thing. We call these type of reactions combination. So these are all combination reactions.